Hey guys, recording the podcast for homework 4 or lab 4.3. This is only blocks 5 and 6, so if you're in block 2 or 3, you're exempt from this lab. I was absent those days and we did not have time to make it up. This lab has to do with something called absorbance. And absorbance just, in layman's terms relates to how much light a substance can absorb. And the first thing that's important to understand is the equation for absorbance is absorbance equals this weird little E, this B, and C. The most important thing to understand is C stands for the concentration or the molarity. Remember, molarity is concentration, and it's defined as moles divided by liters. B is what's called the path length. Okay, that's basically the width of the test tube. Okay, how much light is going to pass through depends on how wide the test tube is. And E is a constant, and it's called the molar absorptivity constant. A very simple equation. The most important thing to garner from this equation is that absorbance is directly proportional to concentration. That is to say, when absorbance goes up, concentration goes up. So we had this large graph, and your absorbance was plotted here. You plotted the natural log of the absorbance and the reciprocal of the absorbance. If this gave us a straight line, it was first order. If this gave us a straight line, it would be zero order. And if this gave us a straight line, it would be second order. So let's go through and look at what we got. This page basically just gave you some directions. What did you notice, though, about the color? We noticed that it faded. Okay, and we were plotting. Let's actually go back to the pre-lab notes. What you were doing is plotting the rate at which phenolphthalein faded. So when phenolphthalein was in a 2- charge, it's pink in the presence of hydroxide. But over time, it grabs onto that hydroxide, making a 3- complex ion that's clear. And this process up here, that's called fading. So we were looking at the kinetics of fading, how long it took for that process to happen. Okay? So let's go back over here with open up Microsoft Excel, make a time, how that both comes. Okay. Alright, so the natural log of time when you did this graph, when you took the natural log of the absorbance, and now notice when we put absorbance in there, it's the same thing as saying the molarity, the concentration, because remember, absorbance is directly proportional to concentration. Okay, and most people got a fairly linear slope for that. And 1 over absorbance versus time, I think for people wasn't as linear. So that tells us a lot. Which graph best approximates the straight line? It was the natural log of the absorbance versus time. So, assuming the hydroxide ion concentration is kept constant, is the reaction of phenolphthalein with hydroxide ions zero first or second order? So, it's going to be first order. Okay, this is because the natural log of the absorbance produced a straight line with a slope of -k. All right. If the reaction is zero order with respect to hydroxide ions, okay, so remember the reaction from the pre-lab notes was P2- plus OH-. This was the pink side, and this was the clear side. Okay. If it's zero order with respect to this, write the rate law equation. All right. So rate equals, well, we know it's first order for phenolphthalein because of what we learned up here. So P2 minus first OH minus 0, and we're going to rewrite that in a more professional form, not showing the 1 and not showing that 0, because anything to the 0 order is 1. What is Beer's law equation? So according to our P-Lab notes, that's Beer's law equation. According to this equation, what is the relationship between absorbance and concentration? Absorbance is directly related to concentration, so it's direct. That is to say, if one goes up, the other goes up. If one goes down, the other goes down. According to Beer's law, what is the absorbance? Okay, so here's the equation, Beer's law. With a molar absorptivity of 0.004, that's this, 0.004, a path length of 1.2 centimeters, okay, and a molarity of 0.2. So you're just going to multiply all these things together. I'm not sure what it is, but absorbance, you can just put ABS after it for the absorbance. I believe there was something more in this, or perhaps these were the only questions. Okay, that's all I have right now. I have this sneaking suspicion that there were some other questions, but perhaps I'm wrong. So anyways, this lab, to review, was about the concept of absorbance. It was a way of measuring the kinetics of fading. As fading occurred, the absorbance went down. Okay, and as plotting the absorbance, the natural log of the absorbance, and the reciprocal of the absorbance, we were able to yield a straight line for the natural log, telling us that it was first order with respect to phenolphthalein. All right, have a great day, guys.